Hello. Today, our group will be discussing the environmental impacts of fracking natural gas and its connection to use as a fuel. Listed right here is what we will be discussing in the next few minutes. Natural gas is a naturally occurring gas consisting mainly of hydrocarbons. Primary hydrocarbon is methane, with a mole percentage ranging from about 70 to 90%. Other components of natural gas include higher order alkanes, including ethane, propane, and butane. These would range from about 0 to 20% of mole percentage. As well as these, carbon dioxide, nitrogen, oxygen, hydrogen sulfide, and trace amounts of hydrogen and rare gases are also found in natural gas. Natural gas is extracted from reserves underground. It was formed from layers of plant and animal decomposition over millions of years. Exposure to intense heat and pressure from below the surface of the earth form the thermogenic natural gas. Another form of natural gas is biogenic gas. This is formed in swamps, landfills, marshes, and other areas with little to no present oxygen. They're formed by methanogens, which are simply microorganisms that produce methane in areas with little to no oxygen. Natural gas is used as an energy source for heat, electricity, and cooking. Along with these uses, natural gas can also be used as a fuel for both automobiles and aircraft. Liquefied nitrogen gas is cryogenically stored for its usage. Condensation temperature ranges from about 100 -20 degrees Celsius to 100 -70 degrees Celsius, depending on the chemical composition of the gas. The advantage of LNG is its comparable density to both petrol and diesel fuels. It can reduce the need to refuel and extend driving range. However, the major disadvantage of LNG is the high cost of cryogenic storage and the upfront investments in both transportation facilities and dispensing stations. In countries like the US and Japan, this would be a viable option. Natural gas is stored in high-pressure tanks within vehicles. The typical storage pressure ranges from about 20 to 25 megapascals. The combustion of CNG is a safer alternative to fuels like diesel, petrol, and liquid petroleum gas because of its fewer CO2 emissions. Another benefit of CNG is the fact that it's lighter than air and can dissipate quickly if leakage occurs. This would prevent explosions from occurring. Liquid petroleum gas, also referred to as autogas, is another alternative to traditional fossil fuels. It is used as fuel for vehicles, heating, and cooking appliances. LPG replaces the chlorofluorocarbons involved with other fossil fuels in heating and cooking, and thus lowers CO2 emissions. While it still results in some air pollution, LPG, being a gas, does not result in ground or water pollution. The main components of LPG are butane and propane, as well as butylene and propylene. It is a byproduct of natural gas processing and petroleum refining. Despite being a safer alternative to fossil fuels, LPG does not have the greatest engine performance. Another issue is that it is heavier than air and can lead to explosions if leakage occurs. Natural gas is stored in high-pressure tanks within vehicles. The typical storage pressure ranges from about 20 to 25 megapascals. The combustion of CNG is a safer alternative to fuels like diesel, petrol, and liquid petroleum gas because of its fewer CO2 emissions. Another benefit of CNG is the fact that it's lighter than air and can dissipate quickly if leakage occurs. This would prevent explosions from occurring.
So now we'll be talking about part 2, methods of extracting natural gas. But before we get into that, we will talk about the top producers of natural gas. In first place is United States with 750 billion cubic meters. Second is Russia with 628 billion cubic meters. Iran was the third highest producer of natural gas with 190 billion cubic meters. And then fourth was Qatar with 167 billion cubic meters. And in 2016, the top consumers of natural gas were the United States, Russia, China, Iran, and Japan. Now we will talk about the extraction methods for conventional and unconventional gas. So for conventional gas and unconventional gas, there are two different methods because conventional gas just uses the natural pressure and pumping methods, while unconventional gas is usually used for wells that are dried up. So drilling is an extraction method for conventional natural gas. Step 1 would be to use a drill bit and pipe to create a vertical hole into the sandstone or the gas reservoir. Step 2 is to pump mud from the surface to the bottom and then to the surface for preparation. Step 3 is cement encases the casing, and within them is the drill pipe and drill bit. Then holes are drilled into the pipe for gas to flow in. And then step 5, the well is plugged and abandoned at the end of its lifetime, which is about 10 to 15 years. So hydraulic fracking is used for unconventional natural gas. Step 1 is the well is drilled at least a mile before drilling horizontally into shale rock. Step 2 is it is cased and cemented. Well has small holes covering the horizontal piping to allow the gas to flow in later. Step 3 is a mix of 90% water, 9.5% sand, and 0.5% additives are pumped in at high pressure, and the sand is added because it helps keep the pathways open to allow the natural gas in. Step 4 is mixture that we just pumped in creates fissures that release natural gas that is released into the well. And as of 2015, in the U.S., there are 21 states with active fracking sites, and there were 5 potential fracking sites. For air pollution, methane traps 25 times more heat than carbon dioxide. There are at least 10 air contaminants: benzene, toluene, carbon monoxide, and more. It affects water pollution, so each well produces millions of gallons of toxic fluid, radioactive material, and liquid hydrocarbons. It also causes induced seismic events about 5.2 in magnitude. And it also causes soil contamination. There's a 5,100 increase in chemically tainted soil from drilling waste over the past decade. Even though the fracking has negative effects on the environment, the U.S. continues to fracking for mainly economic reasons. As you can see, we have a graph with years versus billions of cubic feet per day. So in the blue, we have natural gas withdrawal, and then green is natural gas withdrawal from specifically shale. And then we have market prices shown on the graph as well. And as you can see, with the natural gas withdrawals from shale increasing from 2008 to 2013, there's been a drop in market pricing point for exchange. And then to continue why the U.S. continues to frack is, one, it allows us to tap into tight rock formations that we would not be able to reach with just normal drilling. 2, because America can have energy independence from foreign countries. And 3, natural gas has lower prices over the past 5 years. Therefore, natural gas is 80% cheaper in the United States. Also, the earthquakes are not that big of a deal because they're only about 5.2 in magnitude.
I will be talking about the refinery and the liquefaction of natural gas. So, in step 1, we have a conventional separator here. This takes in raw natural gas right next to the oil well, and it converts it to liquids and gases. It separates everything out. That happens with the force of gravity, so it enters here in the right, and then it just goes to the left and separates. So step 2, we need to remove the water. Step 1 did remove a good portion of the water, but now we need to completely eliminate the water. This can be done by 2 methods, which I'll be talking about, but one of the most common methods is called glycol dehydration. So natural gas is pumped into a bin that has a glycol solution in it, and the water molecules bond to the glycol, and it sinks to the bottom of the tub, and then that gets reused for later usage. The glycol and the water can be separated by heating up the mixture between 212 degrees and 400 degrees Fahrenheit. Another common process is called solid desiccant dehydration. So it's very similar to glycol dehydration, except you need to use solids instead of solutions. So the natural gas is actually dropped from the top of a large absorption tower, and it's filled with many different arrays and beds that have solid desiccants that bond to the water, and as the natural gas falls, the water is removed from the gas. In step 3, I will be talking about the removal of NGLs. So once our water is completely removed, the NGLs need to be separated from the natural gas, and the NGLs then need to be broken down. So one method is the absorption method. This method is very similar to the glycol dehydration, where it uses a solution that absorbs the NGLs, but this is not very efficient. The most efficient process that we have so far is called the cryogenic expansion process, where the feed of natural gas is chilled down to -100 degrees Fahrenheit, and all the hydrocarbons condense while the natural gas remains pure. For the NGLs, these then are processed further down into their pure substances, and as you can see, there are different sectors and products that each can be used for, from plastic bags to gasoline. Step 4, we need to remove the sulfur and acid gas from the natural gas stream. One of the most common processes is called gas sweetening. This is where similar glycol dehydration solution is attached to the H2S molecules within the stream. The solution that is combined is monoethylamine and diethylamine, MEA and DEA for short. Another process that can be used is called solid desiccant, or Claus process. This uses thermal processes and catalytic processes to remove the sulfur and the acid gas. Step 5, we need to remove the mercury. We have two different types. We have regenerative and non-regenerative. Here is a picture of the non-regenerative, which uses sulfur to bond with the mercury. And then this is the process of the regenerative, and this uses mercury instead of sulfur. So then for the liquefaction of natural gas, it's not very easy to transport a gas. So what we do is we condense it down to a liquid for easier transportation. This is done by cooling the natural gas down to -260 degrees Fahrenheit, and it makes for a lot easier transportation.
As we say, the United States produces a large amount of natural gas itself, and United States export and import significant amount of natural gas from the other countries as well. There are two user forms to transport natural gas. First, land to land, and second, an intercontinent. So, for the land to land option, US usually use pipeline to supply natural gas to the domestic and exchange to the Canada and Mexico. This is the overall map of the installed natural gas pipeline in the US. But as we learned in the class, many of the natural gas companies burnt their natural gas rather than sell it to the market, because the cost of construct natural gas pipeline need considerable budget. To construct a natural gas pipeline, we need to install valve with every 5 to 20 miles, compressor station in every 20 to 100 miles. But it is quite expensive to install, but it also has the economic benefit than using a truck. For the second option, many nations use tanker to convey their natural gas to their nation, and natural gas is a suitable form for this option. Natural gas has 1/600 volume of the common natural gas, and it has -162 degrees of Celsius boiling point. So this ship needs special technology to transport natural gas safely. The cost of ship is almost 3 times of general tanker. This ship can transport 216,000 meter cube natural gas, and this amount of natural gas can generate 97 million MMBTU, which is quite a lot. So let's see how big is this ship is. The length of this ship is almost 5 meter, and which means if we stand to the vertically, it is more larger than the Empire State Building, and the width of it is almost same as the Boeing 747, and the height of it is almost same as the Big Ben. And the total area of this ship is just 5 soccer fields. So this is very big ship. So next, now I'm gonna talk about the 2 different methods to store natural gas. First is underground with 3 type, and 2 above the ground. This map is talk about the underground natural gas storage in the U.S. and U.S. can store 1,530 billion cubic feet of natural gas to the storage include underground and above the ground. Underground storage is most common form, and the reason why we use this method is that underground has a stable temperature, which means the temperature change is not that big, and it has a higher pressure, which means it is more controllable to natural gas to supply. The difference of these 3 types is what kind of word they use and how deep it is. So first type is the depleted field, and 79% of U.S. underground storage is this form, and second one is salt. This one takes 11% of the U.S. and less for the number 3. It is cost more than above the ground storage, but it is more safer and more controllable. And this form is the most suitable form to store natural gas in long period. So next is the above the ground storage. It is not the best option, but this is applicable to place not suitable to install underground storage. This storage need compressor and cooler, which means the underground storage doesn't need. This storage is usually used for the short period storage. So next, I will introduce new technology that can skip some steps to make usable natural gas to us. So first is FLNG, floating liquefied natural gas. This technology and ship can skip the liquefy process underground, and because this ship already has the special equipment to condense and cool the natural gas to the LNG. So the company can save the money to install a pipe ocean to the ground and liquefy facility. This ship has economically benefit, but the price of the ship is very expensive. So the next technology is the exactly reverse process of the FLNG technology. We called it FSRU, floating storage regasification unit. This ship can convert LNG to the consumable natural gas to us. It already has some regasification unit, so bring energy from the other country or take LNG from other tanker in the harbor, and then regasification the LNG, and then send the natural gas directly to the pipeline installed in the harbor.
So part 6, usage of natural gas, and part 7, problems and supplements of natural gas. So in this chart, you can see this is the breakdown of the consumption of natural gas throughout the world. You can see this is several regions of the world between Europe, North America, Asia, the Middle East, South America, and Africa, with Europe coming in at 29.1%, North America coming in at 27.3%, Asia coming in at 20.4, the Middle East at 14.5, South America at 4.9, and Africa at 3.9. So this is a look in the United States of natural gas versus the other resources that are consumed. You see fossil fuels in general are at 62.7%, which has been decreasing, with natural gas actually being the highest consumed resource currently in the United States. If you look at compared to other ones, nuclear at 20% and renewables at 17.1. Also with hydropower at 7.5, wind at 6.3, and solar at 1.3. So you see all the renewables going up. Also, you see natural gas going up. And here's a breakdown of natural gas and kind of the sectors that it is broken down into in the United States. So for the first one, we have electric power, which is just generating electricity through natural gas, which takes up the majority, I shouldn't say majority, but a large portion at 36%. The next highest we have industrial at 34%. And this is natural gas as a fuel for process heating and for combined heat and power system, and as a raw material to produce chemicals, fertilizer, and hydrogen. Number 3 usage is residential, which is used to heat buildings and to cook and also to dry clothing. Number 4 is commercial at 11%. Again, used to heat buildings and water, to operate refrigeration and cooling equipment, also to cook, dry clothes, and to provide outdoor lighting. And the last one, a very small percent, 3%, is transportation, which is to operate compressors that basically just move the natural gas through the pipelines. And now the advantages of natural gas. The first one being price. Compared to conventional fossil fuels, natural gas is a cheaper option. Second thing is environmental, which can be a pro and a con. As a pro, it does emit less fumes and less emissions than conventional fossil fuels, but it still does lead to emissions when there are renewable resources that obviously don't lead to emissions. I'll touch on this later. Next one is transportation. So natural gas is much easier to transport between lines and pipelines. The availability of natural gas, there's a lot of natural gas available throughout the world, not only the Middle East, but in America and basically all around the world. Fifth one is multi-use. So basically you can do a lot of different power generation with natural gas, from heating homes to industrial. And then the last one is conversion to hydrogen fuel. Right now it is currently the cheapest option to convert to hydrogen fuel. The disadvantages of natural gas. The first one being flammability. Gas leaks can be very dangerous with natural gas, since it is a highly flammable and highly toxic gas. Number 2 is environmental, which I'll touch upon later. It emits less fumes than your conventional fossil fuels. However, natural gas still does emit some fumes compared to renewable resources such as wind or solar that don't emit fumes. And that leads me into my next one, which is non-renewable. Even though over time there will be more natural gas that is created underneath the surface, but for right now, once we use it, it's done. In our lifetime, it's not going to be regenerated. The last one is installation. It is very pricey to install the rigs and the transportation of natural gas. The initial startup can be a little bit expensive. As I mentioned before, as a pro and a con, is the combustion of natural gas. Natural gas emits less fumes than coal and oil, about 50 to 60% less carbon dioxide, and also small amounts of sulfur, mercury, and particulates. However, natural gas does release some nitrogen oxides, and then reduction in these emissions that natural gas does have is good for public health, because these emissions could lead to asthma, bronchitis, lung cancer, and even heart disease. Another environmental impact of natural gas is fracking. So the problems of fracking break down to 3 categories. The first one is the fracturing of wells requires large amounts of water. This has been a topic of debate because it could be seen that the water used for fracking could be used for other sources and that this could be a waste of water and there's better ways to use it. The second one is large amounts of wastewater at the surface. So when fracking occurs, the water is also pumped with chemicals, and this excess water, after it gets pushed through the ground, ends up sinking or pushing its way up to the top, and then you have a lot of excess water with chemicals in it sitting at the top. This could be dangerous to kids, to wildlife, to plants. This is a big topic right now in fracking. And then the last one is the contamination of drinking water. So there's been reports that drinking water can be contaminated by this fracking water, though no actual documented cases have been proven, and this myth seems to be debunked.
In conclusion, natural gas's impact on the environment is a safer alternative to traditional fossil fuels like coal and oil. Although it still results in some CO2 emissions, and the fracking of natural gas can contaminate drinking water, the benefits far outweigh the negatives. It is cheap and easily transportable, and we have abundant access to it. It is still environmentally cleaner than the other fossil fuels, and it is a reliable fuel source. Thank you.